Today's discussion is one of the confusing question of pair of straight lines. Find the equation of straight lines to the origin and perpendicular to the lines represented by ax square plus 2hxy plus by square equals to 0. So we have to find the single equation of straight lines which passes through origin and perpendicular to the given homogeneous equation of pair of lines of second degree. As you know, this is the single equation of pair of lines of second degree passing through origin. So if you separate these two lines from this single equation, then the two equations will be y equals to m1x and y equals to m2x. So since these lines passes through origin, so constant term c is not present. So these are the separate equations of the given pair of equation of straight line. Now when we combine these two equations, remember while combining the RHS must be 0. So we bring that m1x and m2x this side. We get y minus m1x times y minus m2x equals to 0, and by multiplying and arranging we will get at last m1 m2x square minus m1 plus m2 xy plus y square equals to 0. Again, now let us take the given equation of pair of straight lines, that is ax square plus 2hxy plus by square equals to 0. Now what is the difference between these x square plus 2hxy plus by square equals to 0 and equation 3? Actually they are the equation of same straight line, but directly now we cannot compare because coefficient of y square in down one equation and above one is not same. It is 1 up, down there is b. So let us remove this b by dividing b both sides. So if you divide by b both sides, we get a by bx square plus 2h by bxy plus y square equals to 0 because b and b cancel. So you will get y square equals to 0. Let it be equation 4. Now compare this equation 3 and 4. They are the equation of same straight line. So we can compare the coefficients of their respective x square, y square and xy. So let us write one reason, that is since equation 3 and 4 represent the same lines. So when we equate their coefficients, we get m1 plus m2 as minus 2h by b and m1 into m2 as a by b. Now equations of straight line through origin and perpendicular to equation 1 and 2 are, remember equation 1 is y minus m1x equals to 0 and equation 2 is y minus m2x equals to 0. Now in perpendicular case, what it should be done, I think you know, you interchange the coefficients of x and y and whatever sign is there between x and y, just opposite of that sign you need to write. So equation 1 becomes m1y plus x plus k equals to 0, isn't it? But here already said that it passes through origin, so constant term we should not give, that is k must not write. So equation 1 at last becomes m1y plus x equals to 0. Let this be as equation 5, and similarly equation 2 becomes m2y plus x equals to 0. Let this be equation 6. Now combining this equation 5 and 6, we get as m1y plus x times m2y plus x equals to 0. And when we multiply and arrange it, we get m1 m2 y square plus m1 plus m2 times xy plus x square equals to 0. Now putting the value of m1 into m2 and m1 plus m2 from above, we get, instead of m1 into m2 we write a by b y square plus m1 plus m2 we write minus 2h by b into xy plus x square equals to 0. Now when we take LCM, we get ay square minus 2hxy plus bx square equals to 0. When we arrange it, it becomes bx square minus 2hxy plus ay square equals to 0 is the required single equation of pair of lines perpendicular to x square plus 2hxy plus by square equals to 0. I hope you have understood this solution. So further, if you have any questions to ask, then you can ask the question to our mail. Our email ID is edu.bw123@gmail.com. Thank you very much.